Okay, back again, huh? So we're going to be talking about accelerating motion. Isn't that awesome? So there's three very important equations that you're going to have to know. All right, so yes, they are on the formula sheet that you'll be able to use on your test, including the AP test, but these are three that you really should just know because you're going to be using them all the time. It's really something like that. I'm not very big on memorizing, but even I got these ones down. Okay, so we're going to talk with number one. The first very important equation looks like this, where you have a V is equal to V0 plus AT. All right, this is your first very important equation. Now, this one should seem kind of familiar, because if you solved for A, you would just get your acceleration formula, okay? Because you do V minus V0, and then you divide that difference by t, okay? So this is your acceleration formula, but this is written out in a different way that you're going to use more often than just acceleration. So let's write down what each variable means. V stands for your final velocity. Okay, your final velocity is going to be in meters per second. V0 stands for your initial velocity. All right, that's also going to be in meters per second. Now, sometimes in some places you will see this VF and VI, or VX1 and VX2, whatever, it doesn't matter. But they're the same thing. It's just different labels for the velocities, okay? For me, I'm going to stick with a V0 for any initial thing and just a V plane for a final. Just because that's what I've been doing. That's what I've gotten used to. And I think that makes sense for most situations. All right. A should be familiar territory now. This is your acceleration. That's going to be in meters per second squared. T stands for time. Time is going to be in seconds. All right, so that's your first very important equation. Your very important equation number two is going to be D is equal to D0 plus V0T plus 1/2 AT squared. Okay, this is your second very important equation. Now, this one should look maybe familiar. Maybe you've done it in math class before. That is a very distinct possibility. This is a very popular one, especially when you're studying quadratic nonsense. Okay, so D stands for your final distance or displacement. We'll write displacement, but very often we're going to be throwing those terms around willy-nilly, and you'll get used to it, and we pretty much mean displacement, but we'll say distance. Okay, so final displacement, and that's going to be in meters. This guy right here, his brother, is going to be initial displacement, and it's also going to be in meters. V0 is the same as the other V0. It's initial velocity. You got a time, you got acceleration, you got the time again. So these are the same thing. These will always be the same number. These will always be time. That's going to be in seconds. Now, I just want to make a reference to here, this 1/2. It's always 1/2. It's always 1/2, and it's exactly 1/2. So you don't have to worry about sig figs or anything like that. The 1/2 is always going to be there. And it's always exactly 1/2. There's no estimation. Why is it 1/2? You'll learn about that once you take calculus, okay? Once you know calculus, these two formulas are going to be very nice to you. We're not doing calculus here, so you'll just have to take my word for it. But don't worry, in a few months, there'll be a big I told you so once you learn this in calc class. All right, your third formula. Your third very important formula. Your third formula comes from solving equation number 1 for t and plugging it into equation number 2 and doing a whole bunch of grinding. Okay, you can do this if you want, if you got time, which you're at home all day. I can't imagine that you wouldn't, but I'm gonna write you the end result, and you can have the algebraic joy on your own. All right. So your finally very important equation is v squared is equal to v0 squared plus 2ad. All right. Now, v is just velocity, final velocity, just like before. V0 is initial velocity, just like before. The 2 is always just 2, right? Just like the 1/2. It comes from the 1/2 basically, but so always 2. A is acceleration. D is actually just the same thing as d minus d0, right? So the distance that you cover, it's just usually more practical to think of it as the distance that you cover as opposed to d minus d0. Sometimes you'll see it as x minus x0 or something like that. Same thing, it's just got different makeup on. Okay, so you can get equation number 3 by combining equation number 1 and equation number 2, just like addition. Anyways, we're going to be using these 3, and this is the main goal for today, is that you get a hold of these 3 and be able to solve some motion stuff with them. Let's do the first one together. All right, you accelerate from rest at 4 meters per second squared for 6 seconds. How far do you go? All right, this is similar to last time, but the difference now is we're saying how far do you go. So that's going to be in distance. Okay, the first thing you always have to figure out is which equation you need to use. Now, you don't have to like memorize which one's the first, second, and third, but that's what I'll be referring to differentiate them, just so that we're in the same vernacular. Okay, so we got to figure out which equation do we want. We have an acceleration, we have an initial speed, right? And we have a time, and we're looking for a distance. So I'm going to be using the second equation. I'm going to write it down so that way you remember which one that is. So d is equal to d0 plus v0t plus 1/2 at squared. All right, I'm solving for distance, so I don't need to do any rearranging at this point in time. Now, how far do I go? So I want to know what's my final distance. What am I starting at? Well, I'm starting at wherever I'm starting, so it's just going to be 0. I'm starting at the origin, right? Plus v0, I'm starting at rest, so I'm starting at 0 velocity times time for 6, right? You know, 6 times 0 is 0. So plus 1/2 times a is 4 times t is 6 with the squared. All right, I'm doing some quick maths here. We got 0 plus 0 plus 1/2 times 4 is 2. 6 squared is 36. So that's going to be 72. So 0 plus 0 plus 72 is 72 meters. And that's how far we'd go by accelerating. Ta-da! And this is the kind of thing you'll be doing. So you have to figure out which equation first, and then plug it in and get your answer. Now, if you picked the wrong equation, let's pretend you picked the wrong equation. I'm going to write down the third one. Okay, so I want to give you the fallback scenario. So you just pick one. Let's say I pick v squared equals v0 squared plus 2ad. All right, so I would plug in distance, what I'm looking for. Acceleration is 4. 2. v0 is 0. But I don't know what my ending velocity is. If you find something you don't know, you probably picked the wrong equation. Okay? That's what would happen if you picked the wrong one. Okay? So, you know, you don't want to do that, but it's not the end of the world if you do. Okay? Let's do the next. You're traveling at 42 meters per second and brake to 30 meters per second, accelerating at there. How long did it take? By long, we mean time. All right? So I just want you to decide which formula it is, okay? So pause the video, figure out which formula, and then we'll come back to you. All right, you should have picked formula number 1, which is V is equal to V0 plus AT. All right, the reason is because we have two velocities, acceleration and time. This one is also your normal acceleration formula. So if you said that, that's fine too. All right, but we want to solve for time. So I'm going to solve for time here. So I'm going to have V minus V0 over A is equal to T. All right, now I can just plug stuff in. So I'm going to have V, my final velocity is 30, right? Because remember, your ending minus initial velocity is 42 divided by 4. You can type that into a calculator, or you can just get, whoops, -3, but you can't have a negative time. Now here's the deal. Remember, so your acceleration should have been negative there. Oh well. So I should have put that because you slowed down, but it told you that. So either way, you're going to have a positive answer for time. So you're going to have 3 seconds. It took you 3 seconds to do that. Do we understand how the negatives worked into there? This top part was negative, and since you decreased velocity, it kind of implied that was negative. Don't worry too much about it, because the more familiar you get, the easier this comes to understand. It's a practicing thing, and we're going to do a lot of practice. Let's do the next. A ball falls down at 10 meters per second, or accelerates down. You could think of how long will it be in the air. If it's dropped from 85 meters, what will be the speed at the bottom? All right, let's just do it in order. Let's keep it simple. The first thing we have to decide is which equation are we going to use. All right, so pause the video, decide which equation we're going to use. All right, you should be using equation number 2, which is going to be D is equal to D0 plus V0t plus 1/2 AT squared. All right, pause the video, see if you can figure out this first one, the how long, the time. All right, let's see if you did it right. So what's going to be our ending distance? Our ending distance is going to be 0 because we're going to hit the ground. Our initial distance is 85 plus our V0, it's just dropped, so it's going to be 0, dropped from rest, plus 1/2 A, which is 10, times T squared, which is going to be right there. Now, before we solve this, I do have a confession to make. You could have set it up a different way, and it would have been just fine. All right? So if you figured, well, it's going to travel 85, and you're starting at rest, you would have been okay. So what I'm doing is I'm dropping it down, so it's going to be accelerating downwards, so my acceleration would have to be negative. If you did it the other way, your acceleration could be positive and you'd be fine. Both ways are totally legit, and I don't care which way you do it because you'll get the same answer either way, but it's just a different way of thinking about it. I'd love to go over all of that with you more, but since you're not here, you know, I just have to talk to you about it. So we're going to solve for T. Oh, we should have solved for T before we got all this messy stuff in there. But, oh well, this is gone. So kicking the 85 over there, I'm going to have negative 85 divided by 1/2 times 10 is 5. Negative 5 equals T squared. 85 divided by 5 is 17, right? Is equal to T squared. So that means T is going to be the square root of 17, and the square root of 17, let's figure out what that is. Yeah, it's 4.1, all right, seconds. All right, now in physics, we're going to go and get a decimal answer, all right? I know in math class you'd want to leave it as a square root of 17. we're going to go for a decimal here because we're very real world applicability. Okay, unless it tells you to leave it exact or something like that. But normally we're going to go for a decimal answer, especially if it gives you real numbers. If it doesn't give you real numbers, if it's just like solve for, then keep it in the radical. All right, what will be the speed at the bottom? So to find the speed at the bottom, there's a couple ways you can do this since we already have half of the work right there. I'm going to use a different formula. I'm going to use equation number 3. Oh, sorry. You know, you could do either one. But do it whichever way you want. Pause the video. I'll help you doing this equation. All right. So v squared is equal to v0 squared plus 2ad. All right. So v squared, I'm solving for that, is equal to v0. v0 is going to be 0 plus 2 times acceleration times the distance, which is 85. All right. So v squared is going to equal 2 times 10 times 85, which is going to be 100. Let's see, that's 850, which is going to be 1700. All right, and then I have to square root that. So v is equal to whatever, 1700 to the... All right, so, oh, yeah, it's just going to be 41 meters per second. It's going to be going pretty quick. All right, so you can do it a different way and do that. What do I mean? I mean you could use equation number 2. Equation number 2? No. Sorry, we already used equation number 2. Equation number 1. So because v is equal to v0 plus at, starting from rest, you know what the time acceleration is. It's going to be 10. And you know what the time is. Time is 4.1. So v is going to be equal to 41 meters per second. All right, let's talk about advantages. Number 1 is always the easiest, so it's always good to know. The reason why I use number 3 is because I don't like using our calculated value. I'm an elitist, what can I say? So I like using only the things provided if possible, right? But sometimes that's not really an option. You should have gone number 1, I just didn't think of it. Spoiler alert. All right, I think we got one more to try. All right, so just try the first question, and then I'll catch up to you. I want you to figure out which equation you want, and then solve it, and then I'll meet you, okay? So go ahead, pause the video. All right, so let's see. A bullet hits the gel, stops after there. If its initial speed, what was the acceleration? You'd have to use number 3 here. Okay, so v squared is equal to v0 squared plus 2ad. V squared is going to be, oh, before we do that, it would be easier for us to solve for acceleration, right? So let's solve for a first, because the reason why we're doing this is we're practicing working without numbers and just working with the variables. That's the reason why, okay? So acceleration is equal to, let's see, so we're going to have v squared minus v0 squared, and then we're going to be dividing by 2d, right? Now we know all of these values here, so v squared is going to be 0 squared minus 480 squared divided by 2 times 2.4. All right, ta-da. All right, so we're going to type that into our calculator to figure out the acceleration. Now, you got to be careful when you type it in, right? So 480 squared. When you divide it, you have to use parentheses around the 2 times 2.4 or some other way to work around it, right? You can just type in 4.8, but I'm under the assumption that I don't want to assume that you can multiply stuff like that. Okay, so anyways, your acceleration is going to be a big number. It's going to be 48,000 meters per second squared. Ta-da! Right, because it's pretty intense. That wouldn't feel nice. Oh, and negative. It's going to be negative because we're decelerating. I didn't type it in the negative. Okay, anyways, how long does it take? We'll give you a second to try this one out. Pause the video. Go for it. All right, hopefully you figured it out. How long did it take? There's a couple ways you could do this. I would just use equation number 1 this time. I'm trying to do either one. So V is equal to V0 plus AT. All right, solving for T. T is going to equal V minus V0 over A. I know what my starting or ending velocity is. I know what my initial velocity is. And I know what my acceleration is now because I just figured it out. So we can work that out. Ta-da. Well, 0 minus. Don't care about that. So you can cross out the negatives there. So it's going to be T is equal to 1 over 100. But we're not going to use fractions like that. So we're going to go with a decimal like that. But we should do... Okay, what we were saying is we got to put a 0 there because we've got 2 sig figs here, 2 sig figs here. Everything's got 2 sig figs. So you should have 2 sig figs for your answer. It's making it 0.010 seconds. There. Okay. So those are your 3 big equations. These are important. These will chase you the whole year. Okay. So I know. It's more than usual that these matter. Okay. We'll see you tomorrow.